Hi, welcome to our very last complex numbers video. This video is about locus or loci. Loci is the plural and it is the set of points which satisfy a condition or a rule. So straight into example 1. We want the modulus of z equal to 4. Well, z is a complex number which we write as a plus bi. And we've got a real bit and an imaginary bit. And we want the modulus of z. And to work out the modulus, we take the real bit, a squared, plus on the imaginary bit, b squared, and square root it all. Now, if I square both sides, I end up with a squared plus b squared equal to 16. Now, this represents a circle. For those of you who are a bit rusty on your level 2 graph work for circles, go back and revise it. It's a circle with a centre 0 and a radius of 4. Now, that shouldn't surprise you because back at the start we were told that the modulus is equal to 4. And so these red points all the way around the outside of the circle are all the points which satisfy this condition and have a modulus of 4. All right, example 2. The modulus of z plus 1 is equal to 2. So again, I'm replacing z with a plus bi plus my 1. And I'm putting my plus 1 at the start so that I've got a real bit of a plus 1 and an imaginary bit of b. Now again, we're talking modulus, so we have to square the real bits plus the imaginary bits squared, all square rooted to get the modulus. And again, I have to square both sides to get rid of my square root. And I'm left with this equation, a plus 1 all squared plus b squared equals 4. And again, this is just a circle equation which has moved to the left by 1. That's what the a plus 1 does in the brackets. It moves it to the left. And it has a radius of 2, because 2 times 2 is 4. But here's example 3. Let's find the locus or loci of points which satisfy this condition. We have z minus 1, the modulus is less than 3. So, again, I'm replacing z with a plus bi and my minus 1. Again, I'm putting my minus 1 at the start with my a because I want my real bit to be a minus 1 and I want my imaginary bit to be b. Again, we've got the modulus, so we once again work through the modulus of squaring the real bit plus squaring the imaginary bit, adding them and square rooting it all to get my modulus. Again, I have to square both sides to get rid of my square root, and I'm left with this equation, a minus 1 all squared plus b squared is less than 9. Now, if it was equal to 9, it's still just a circle equation, and the a minus 1 means it's moved to the right this time. Remember, a is your real number. That's why it's kind of like the x-axis. So it's moved to the right, one square on the x-axis, and it has a radius of 3, because 3 times 3 makes 9. But because we have got a less than, I'm colouring in all the points that are less than 9 because to satisfy this rule, we've got to be less than 9. So we're colouring in all the points less than that. So that's why I've coloured the circle in. And notice I've also put a dotted line around the circle because I'm not allowed to actually be part on the edge of the circle. Our final problem is number 4. The modulus of z minus I is equal to the modulus of z plus 1. So once again, I'm going to replace z with a plus bi. So in the left, a plus bi minus I, and a plus bi plus 1 on the right. On the left, notice what I'm going to do. I'm going to factorize out the I to get b minus 1. And on the right, I'm just going to shuffle things around to get my real bit together. So on my left, I've got a real bit of a and an imaginary bit of b minus 1. And on the right, I've got a real bit of a plus 1, and my imaginary bit is b. Again, modulus, so let's work through that process once more and then square both sides. I can expand out the left-hand side and expand out the right-hand side, and I can then start doing some simplification. So if I minus a squared off each side and b squared and minus 1 off, I'm left with minus 2b is equal to 2a. And if I divide everything by minus 2, I've got this equation b is equal to minus a. Now just think of b as the imaginary, which is your y-axis, and a is your x-axis. It's just y equal to minus x. And that represents a straight line graph coming down in the negative direction. And that's the set of points which satisfies this example. Thanks for watching.